Okay, so now we are on 2005B, question 1. And so for this one, we have a student of mass M, and notice they don't give us any numbers. Mass M stands on a platform in an elevator in a tall building. The positive direction is up. So first thing it asks you to do is draw a free body diagram showing and labeling all the forces acting on the student, who is represented by the dot below. So when you're in an elevator, the only two forces that you are feeling is, of course, gravity, which is going to be mg, and basically the floor of the elevator, which is going to be your normal force, the force of that surface of the floor. Now we want to derive an expression for the reading on the scale. The reading on the scale is going to be your normal force. Because, as you guys will see on Friday, this normal force, the scale reading, is going to change depending upon whether you're going up and stopping or going down and stopping, and so on and so forth. So this normal force changes, but this mg will not change at all because your mass stays the same and the acceleration of gravity stays the same. So the reading on the scale is going to be the normal force because it's going to be reading what this upward force is. And so let's go ahead and do that. So we have got the sum of the forces equals your mass times the acceleration of the elevator, because it is accelerating you either upward or downward, and it's going to equal these two forces. So we've got our normal minus our mg. All right, because we said normal is going to be positive because it says up here that upward is positive. Okay, so we're solving for normal, so let's add mg to both sides. And so we end up with normal equals this MA plus this MG. And just to make this kind of look a little prettier, we can take this M out and say normal equals MA plus G. And that is how you do part B. All right, and so now the next part is going to actually give you a graph. And we see that this graph is acceleration, and, well, they give us diagonal lines on this graph. All right, thankfully we don't have to do a whole lot with those diagonals. Remember, these lines are called jerk, and this is something that we're really not going to be seeing in this class except for right now. But we're not going to really do anything with it. And so we get this graph. It's, like we said, an acceleration versus time graph. And the first question wants to know, during what time intervals is the force exerted on the platform scale by the platform scale on the student a maximum value. All right, so when your bank account is at the max, are you going to have a negative number or a positive number? You are going to have a positive number. And so that means that when our acceleration is positive, that means that the force is going to be at the very highest, at its very maximum. And so we see that the acceleration is at its highest. And the reason why we know that, remember, because the sum of the forces equals ma. And so and also we found that normal is going to be equal to this ma plus g. So we know that this acceleration is related to this normal force. And so we see that it is between 12 to 16 seconds that our force exerted by the platform scale, which is our normal again, is going to be at the maximum between 12 to 16 seconds. 12 to 16 seconds. So calculate the magnitude of that maximum force for a 45 kilogram student. So we are finding this force right here, this normal force. So we just use that formula that we just derived, and we see that the student weighs 45 kilograms. Our acceleration, looking at the graph, we see going over, it is at 1.2 because we see that these are intervals of 5, so that means these are all 0.2. So we have 1.2 plus 10, and when we multiply that all out, we should end up with an answer of 504 newtons. So the next part, during what time intervals is the speed constant? The speed is always constant when acceleration equals 0 meters per second squared. So we look back up here and we say, oh, where's our 0? It is right here. And so that means that between 7 to 10 seconds, we have 0 acceleration, meaning our velocity is constant, and between 17 and 20 seconds. So that's going to be our time. So when t equals 7 to 10 seconds, and when t equals 17 to 20 seconds. This is your answer.